Welcome to the Chapter 1 review video. I'm going to go over some of the questions found on your Chapter 1 study guide. So let's get started. The first one says, which of the following relations are functions? Now, one thing you could do is solve each of these for y, if that makes it easier for you to see. So this one would give me y equals x minus 2. The bottom one would give me y equals 2 minus x. Now we can see that all three of these are just equations of lines. If you were to graph them, you would see they're all lines. And all lines are functions. So therefore, all three of these are actually all functions. Find the range for f of x is equal to x squared plus 1 for x is greater than 0. One thing you can do for the range is you can graph it if that makes it easier for you to see. We know that this is going to be a parabola because of our x squared term, and it's going to be shifted up 1. So we can say that our range is going to be y has to be greater than or equal to 1. And again, that's because the image we're going to get is a parabola facing up. Find the domain. Remember, for domain, specifically with fractions, we cannot get a 0 in the denominator. So we'll take our denominator, set it equal to 0, and solve. So x cannot equal 2 for our domain here, because if it equals 2, we get a 0 in our denominator, causing our function to be undefined. Find the range of the function. If you just look at the function, we can see that this is an equation of a line. And again, usually for a line, we would say that it is all real numbers. However, they do give us a condition. X cannot equal 1. So when we plug in a 1 into our equation, we'd get y cannot equal 3. Because at x equals 1, we would get y is 3. So therefore, our range is also restricted. So y cannot equal 3 because x cannot equal 1. Determine whether 5x squared plus 3x plus 4 has a max or a min. Again, this is a quadratic function. This should be a function that you should be able to look at and instantaneously know what the graph looks like. So we know that this is the x squared term is going to tell me if it's a max or a min. Because it's a positive number, we know it's going to be a smiling parabola. Therefore, we're going to have a min as our vertex. So in this case, we're going to have a min. Where is the function 4 times the quantity of x plus 4 times the quantity of x minus 6 to the third power greater than 0? For this one, I just graphed it. And we want to know, where is it greater than 0? So these are the values where the function is greater than 0, where it's above the x-axis. So there's two places where that occurs. It occurs when we have values of x is going to be, we can say, greater than -4, and when x is less than 6. Now we would say or, because in the middle between the two, we can see that it's negative. For which values would the graph be below the x-axis? In this case, we did the same thing. I just graphed it. Now, any numbers between -5 and 5 would work. So if we wanted to say, well, at 4, we would know that the graph would be below the x-axis, because anything between -5 and 5 would give me a number or a value that would be under the x-axis. So any number between -5 and 5 would work. So we could say y equals 4. Or at x equals 4, or x equals -4. So anything that would fall between these two numbers would be a correct answer. This one says find f of g of -4. So to find this, our first step is to plug in a -4. We're going to find g of -4 first. So I'm going to plug in a -4 for my x and solve this. So g of -4 is going to equal to 1 squared. So g of -4 is just equal to 1. Now that I know that, really what I'm looking for, okay, we know that this whole thing right here is just a 1. So then all I have to do is really find f of 1. So I would say 7 over 1 plus 2. So my final answer here would just be 7 over 3. Find f of g of x. Again, this is the same idea as we just did. So remember, when I wanted to find f of g of x, I take whatever my g of x is and plug it into the x value of my f of x. So in this case, f of g of x, we would say is equal to, well, I'm going to plug in my x to the third. That's my g of x function. Don't forget the squared that comes with the x from the original function of f of x. That's a common mistake students make. And we can simplify this even further. We can say x to the sixth plus 1. Says find g of x if g of x is a resulting function from moving f of x equals x plus 2, right 3, and up 4. So remember when we're doing right, left, and right, we're dealing with inside of the parentheses. Right is negative inside of the parentheses. So what I would say is my g of x function would be equal to, well, x plus 2. Because I want to move it right 3, I'm going to say minus 3. So I'm going to get in my parentheses minus 1. And then up 4 is just plus 4. And that would be my new function. Let's see if I can write that 4. It's not letting me, but it should be a 4 on the outside. Let's see if it lets me. Okay, rewrite it. Rewrite sine x if the function is stretched vertically by a factor of 5. Remember that amplitude is what stretches our graph vertically. So if I wanted to rewrite this so that it would be stretched vertically, I could just put a 5. Okay? And that's going to stretch my graph vertically. It's also known as your amplitude of your function. What is the domain? Again, we don't want 0 in our denominator. So what we can do is take what's inside of our parentheses in the denominator, and we don't want it to equal 0. So x cannot equal -2, because if it does, it would give me a 0 in my denominator, causing our function to be undefined. Find the range. Again, with range, I always recommend to graph, but you can also walk this through logically. We know that we will never have a negative number coming out of a square root because we can't have negative square roots. Therefore, if we can't have a negative under a square root, we know that our y value is always going to be greater than or equal to 0. Is a function even, odd, or neither? Remember, to determine if a function is even, odd, or neither, we would replace the x's with a negative x. If when I replace my x's with a negative x and I get the exact same thing as the original back, we would say it is even. If I replace my x's with a negative x and I get the exact opposite of what I started with, then we would say it is odd. If we have a mix, some of them stay the same, some of them turn opposite, then we would say neither. So I'm going to take our function that they give us and replace all of the x's with a negative x. So then I'd get 5 divided by negative x plus the absolute value of -2 times negative x. Okay, so we know that the absolute value is going to stay exactly the same, because even if I plug in a negative x, its absolute value is going to stay the same. But my first part, my first term, actually turns into the opposite of the original, because that negative, it becomes -5x, or 5 divided by x. So this part would be opposite, or we could say odd, and this part would be even. Therefore, it would be neither even or odd. Find the period and the amplitude. Remember, we kind of talked about this before with the vertical stretching. Our amplitude is just the first value of the number our trig function is being multiplied. Our period comes from the equation 2 pi over b. And our b value is usually the number in front of x. So in this case, we would say 2 pi divided by 2. My 2's cancel. So my period would be pi, and my amplitude would be 3. And that's it for Chapter 1 Study Guide. I know I went rather quickly, and that's because this is a video. So you can stop this, pause this, or rewind it if you need to.